those questions. Now, before we get started, I just have a few polls here, just again asking a few questions as to why we might be here today. First one, I'm going to go ahead and launch, if you wouldn't mind answering the question, is how often do you use multibodies? Pick the one that most closely represents your usage of multibodies today. Okay, we got about 50% of you voting here. Okay, I'm going to go ahead and close that and share with you those results. So you can see we have a pretty good cross-section of individuals here today. My focus on this particular presentation was from the very basic to some of the more advanced functions for multibodies. It's not a very hard topic by any means, and a lot of the functions are very easy to use and pretty intuitive, and you probably run into most of them. But what I learned as I got through this is that multibodies really touches a good portion of the software now with the whole mold design and weldments environments using multibodies currently. We're going to kind of try to dispel some of the things that SOLIDWORKS even puts in their own help menu about multibodies as we get going here. So let's look at one more poll here. I want to find out how many of you have an idea of when multibodies were added to SOLIDWORKS. Now I bring this up because I can remember, I've been doing this maybe 11 years, and I can remember demoing to organizations such as yours and running into situations where I just could not perform an operation without rethinking my strategy. And once multibodies came around, I had really a good bit of flexibility in doing things. And a lot of times it had to do with the shell command, where you want to shell out some portion of the solid but not all of it. And you've defined that solid up front. I'm going to go ahead and close this and share with you the results here. It was 2003 that it was added. So it's most of you know that it's been there for a while anyway. It was added in 2003 with pretty close to the functionality that it has today, except they've started to add the ability to use multibodies in many different areas of the software. Now, I'm going to keep this presentation very simple and to the point, and wanting to show you as much related to multibodies within the interface as I can. First thing we want to talk about is, what is a multibody? For those of you who have not used it, it's really a part document that can contain multiple solid bodies that are not connected together, or can or cannot be connected together. Multiple bodies, you can do operations to the individual bodies, like adding individual features, changing names, adding materials. And that's a lot of what we're going through today, is looking at all the different things that we can do within the multi-body environment. And we're going to end kind of with this, the fact that we can now create exploded views and bill of materials and all these other things related to multi-bodies. And we'll show you some tips and tricks with that as well. Now, this is straight from the SOLIDWORKS help. And as I put together this presentation, I really think that this general statement is getting very, very blurry as we move forward with the SOLIDWORKS product. Let me just read this for you. Multi-body parts should not replace the use of assemblies. The general rule to follow is that one multi-body part or not should represent one part number in the bill of materials. A multi-body part consists of multiple solid bodies that are not dynamic. In other words, they don't move relative to each other. And what you lose out on are things like move component, dynamic clearance, and collision detection if you don't use assembly documents. And that still is true today, is that you do lose out on some of these tools. But I want to show you just some tricks as it relates to bill of materials and stuff later on here. Now, I've just listed out all the commands that we're going to kind of cover today. You can kind of see those and read through those. All of these have some effect on multiple bodies within a single part. Everything from mass properties to being able to explode them to mating those multi-bodies together. So that's what we're going to cover today. I'm going to kind of just slide my presentation over to my other screen here so I can follow our list to a T here. So again, any questions that we have along the way, please post them in the questions section. So let's just start in SOLIDWORKS for a moment and just cover the basics of creating a multibody. I'm going to just do this from scratch with very, very basic geometry, as you probably would have guessed. We're all used to the typical environment where we're creating solids. Those solids we create other solids on top of. So as I start to build these other solids, there's commands within the interface that dictate whether or not we're going to go to a multi-body environment or not. As I'm extruding the second extrude here, there's an option in the extrude dialog, merge result. Now, it doesn't only exist in the extrude dialog, it will exist in sweeps and lofts and other commands that create solid geometry. Now, if I let this stay on currently, you'll see that there is a folder in the tree called Solid Bodies that lists a number next to it. Now, let me start off just talking about this folder, because some of you may be having trouble even seeing that a folder exists. If I go to my Tools Options and to my Feature Manager under System Options, there's a section called Hide Show Tree Items. This is where we tell the software when to turn on certain folders or features within the feature tree that I need to see. And the one in there I want to point out is for solid bodies. If I set it to show, it will show all the time, as mine does right now. If I set it to hide, it will hide all the time. If I set it to automatic, what will happen is as soon as the part that you're working on contains multiple solids that are in the file itself, it will then show the folder. You'll notice I put it to automatic here, and the folder no longer exists. Another way, if that folder does not exist, I want to point out that you can retrieve it by right-clicking and going to Hidden Tree Items. Under the Hidden Tree Items, you can actually get to the commands that you would find relative to solid bodies, but you won't necessarily see it in the tree. Now, if I were to go back and decide that I wanted to turn off the merge result command, which breaks the connection essentially to the shared spaces of these two features, you notice that the folder now does show up in the feature tree, and underneath that folder I now have two solid bodies with their own set of names. Okay, this is the basics behind multibodies, the ability to have more than one inside a single file. Now, you can create the more than one body using some other techniques. Here's an example of using contour select. This is a command where we are able to select individual portions of a sketch to actually extrude. And in a single operation, I can go ahead and create more than one body. We can give it some distance, and the result is, again, more than one body, each created separately. Now back to my original part here. When you have more than one body, you are able to perform operations on the individual bodies. Now, if I were to take this edge, which because they're multibodies is no longer shared by the two features, and I decide to add a fillet to it, no matter what the radius of that fillet, you can see that it clearly sees there's no connection between the two, as if something's sitting on a table here. The alternative to that is, if I put these two back together, we're used to this type of thing happening where we come in and we fill it between the solid. Let's edit my fillet here, and it actually creates a junction between the two. And that's what we're used to today. Now, I want to talk a little bit about mass properties, one of the first things on our list. Here's an entire assembly that is in, we're going to use this for an example for a lot of our stuff, that is in as a part file where each part is listed as a separate body. Now, if I go to my tools, mass properties, by default, you'll notice that it always selects the entire part. Well, one of the ways Multibodies is integrated within SOLIDWORKS is the ability to select an individual body, whether that be from the graphics area or from the folder list. If I select the single component, it's got to be selected from the Solid Bodies folder, you'll have to hit recalculate, but it will go ahead and calculate the mass properties of that selected body. Now that brings me to another topic. One of the other things that we're capable of doing for each individual body that we create is the ability to apply a material to a specific body. So in the case like this where I'm kind of going against what SOLIDWORKS says in the help, that we can't really have an assembly in a part, I do have the ability to distinguish between the multiple materials. If I want something to be, this to be plain carbon steel and I want this to be something different, I can absolutely do that. Now what happens in the mass properties, if the material is not assigned, it's going to use a default material. Okay, whatever your default is in your tools options. But if it is defined, it will use that for the mass properties. Okay, so I wanted to point out the fact that it does show up here. Now on top of that, I'm going to just pull up my feature tree a little bit, because once you have all these bodies, they really can be treated quite differently, almost the same way as we do in the assembly. First thing I want to talk about is the display pane. The display pane is here for us to turn on and off transparency, turn on and off our rendering style, or display mode, hidden line, visible, hidden, remove, set our colors, and to hide and show individual bodies. Now each body you'll have access to all of those individual items. So if I wanted to make that wireframe or hide it, I can do that all from here. Individual to a single part file. Again, we're treating the body as if it was a separate piece that we can perform separate operations on. The same thing goes if I go to the appearance section, which is where I add colors and those types of things. When I go into the appearance section, you'll notice that the software's smart enough, because of where I initiated it, to automatically use the select bodies option with the body that I've selected, and I can go ahead and make my changes here, and it changes it for that particular body. Okay. Now this is imported, so the faces actually have the colors, so it's a little bit more complex with this particular one, but you can change those colors as well. Now continuing to look at the right-click menu and some of the options that we have relative to bodies, I want you to point out that we have also a right-click menu for the display. We have the ability to create folders. So as you get to the situation where you have a lot of different bodies disconnected, you may want to organize things. Like, for instance, I have a bunch of bodies here that represent my low pressure valve subassembly. If I control select the bodies, I can come in here and say add to new folder, and it creates a subfolder that I can name whatever way I'd like, low pressure valve in this case, and I can start to organize all of the individual components inside this assembly. Now, I say assembly, but we're still, again, dealing with a multi-body part. Okay, so that's one thing here. Now, any of the bodies can also be deleted individually. When you go ahead and delete a body, okay, it asks you what body you would like to delete, and then it shows up as a feature at the bottom of the feature tree. Therefore, if you wanted to roll back before it, the body would show up. Roll after it, the body will come back. Again, being able to perform a lot of different functions to a particular body. Another thing that we want to talk about is the ability to export an individual body. Can you imagine if you would have designed out this entire assembly in a single part file? Now you wanted to export just one of them to another format. I just stepped to send to a customer or prospect. We know what it's like if you open the part file and if there's only one part in there, one solid body, it's very easy to do a save as. Now to export an individual body, what you do is you select the body, pre-select it, and then you do your file, save as. And I'm going to just save this to this folder as a, let's say a step file. Give it its name. Now once you do that, because I pre-selected the body, I now get an export option that asks me which bodies I would like to export. Now, because I pre-selected it, I can say selected bodies and say OK, and I've essentially taken one single body out of this assembly into another location. Okay. Let's talk a little bit about some of the feature control that we have with multiple bodies. Let's say I wanted to put a small hole feature in through the parts. Now, when I'm in a part file, I don't need to do edit body or any other function to continue to create or affect the solids that are here. So I can just sketch as is right within the interface and dimension as I would typically dimension. Okay, there's nothing different there. But when I actually go to create the individual feature, okay, I have a new section in the extrude dialog, and you'll see this in cut, extrude, loft, sweeps. You'll see it in a lot of the feature creation tools inside of SOLIDWORKS. But let's say I want a through all hole. I want a reverse direction. Now here I can tell the software which bodies I want this hole to go through. Now let's just say, for an example, I didn't want the hole to go to this outside rubber piece. I can turn off auto select and select the body I want the holes to go through. This happens to be the housing in this case. And once I accept that, you'll notice that there is no hole on the outside. That's a, I'm sorry, I did a boss extrude. Let me do a cut. Let's see here. We'll use a sketch and do a cut and pick the inner housing. There we go. You'll notice that there is no hole on the outer rubber component of this particular part, but I was able to cut through the inside or the selected bodies to make sure the holes go through the proper locations. So very nice to be able to control what's affected by a particular feature. Now that being said, let me go to another example, because as you design in a multi-body environment, I'm just going to use one of these other examples here that I have. Let's use that one. As you design in a multi-body environment, in this case I have two separate bodies, a couple things happen. Every time you add a feature that affects a body, the name of the solid body changes. So for instance, if I select the fillet 5 body, you can see it highlights in the graphics area, but watch what happens if I come in here and add a chamfer to the lip and accept it. There's no longer a body named fillet 5. Fillet 5 becomes chamfer 1. Okay? Now one way to combat that is, I'm just going to roll back for a second here. And I'm going to rename fillet 5, let's say right hand. And by doing that, I've given it an explicit name, so when I apply a new feature to it, it doesn't change its name. Now, if you're planning on working in this multi-body environment, as you get your body count gets larger, it becomes very, very hard to figure out, you know, where's everything, especially in weldments, molds, those kind of things. So renaming is important. Okay. Once you have the body up and renamed, it will not change names. However, there's another feature that allows you, again, to see which features belong to which solid body. Because here I'm sitting with, what, 10, 15 features, but only 2 bodies. How do I know what this extrude goes to, or this fillet? If you right-click the Solid Bodies folder, there's an option in there called Show Feature History. When I turn on Show Feature History, I can expand the individual bodies, and it shows me separate feature trees for any features that have affected those 2 bodies. You can see Extrude 1 is for one of them, Extrude 2 is for another. Okay, it allows you to get a very different look into the bodies and the features that were used to create them. Okay. Now, for this example, let's talk a little bit about patterning of bodies. If we pull down the pattern pull-down menu, which mine has linear pattern, circular pattern, mirror. Let's say I wanted a linear pattern. Let's do circular. A circular pattern. I'm just going to use an axis here, temporary axes for my center. Now, in these commands, you'll have a section called Bodies to Pattern, where you can actually take an entire solid body, like this in this case, and pattern it around an axis. Now, if I was using linear pattern, I could pattern it in a direction. If I was using a mirror, I'll have a bodies to mirror. So there is some integration with some of these other tools as you're seeing. Now, in this particular case, I'm just going to roll back for a second. This is one of those examples back in 2003 that was a lot harder to accomplish. If I, in 2003, had these 2 solid, what look like cups, and I then try to create a feature that goes between them, which I'm going to go ahead and do here. We're going to go ahead and extrude. I want you to notice, first of all, one of our end conditions when you're working in a multi-body part is called up the body. Up the body allows you to pick an entire body that you want the feature to stop at. Okay, that's real nice. Now that I've done an up the body extrusion, you'll notice that my folder has now disappeared in my feature tree. Very simply, it's because the merge result option is still on by default. Now, unfortunately, there is no way that I know of turning the merge result, well, I'll say that a different way. There's no interface method or option in the tools options to turn off merge result by default. However, there is a tool in the, if you make this part a weldment, even if it's not going to be a welded frame, that will automatically turn off all your merge results tools within the commands. So a little tip there, if you're working in multi-bodies and want them off by default, just tell the software it's a weldment. It will go ahead and do that for you. Now, as I was discussing back in 2003, this was an example of a part that if you didn't think far enough ahead, you were going to have trouble performing an operation. Because back in 2003, when somebody said, now I want you to shell this, and I want one of the cups to be 1/4 millimeter, the other to be 1/2 millimeter. Well, we know if we do a shell operation that we can go ahead and do multi-thickness. That's not a big deal, right? I can pick, this face and this face for 1/4 millimeter, and then I can make a selection to another face and make that 1/2. Use the bottom face, make that 1/2. Now what happens, however, well, this one has some rebuild errors. It might be a little bit too thin. But what happens is the center portion actually gets shelled out as well. So how would we perform this operation any other way to actually not shell out the center, but keep the two separate ends shelled out? Well, again, that's where the merge result option comes into play. So if I turn off the merge result, I now have 3 bodies listed in the tree. I can come in here and perform individual operations on those bodies. So I can shell one, shell the other at a different thickness. Okay. If I do a cross section here, you can see that it is not shelled in the center. Now that brings up another command that we would typically use in the multi-body environment, because at this point we have no way of putting these bodies back together. If I go back to this boss extrude command back in history of the part, it's going to change the order in which it calculates the operations, and it's going to try to shell the center again. A new command possibly for you is called a combine. It's found under Insert Features. The combine command is, I'll say, incorrectly named in some ways, because you can combine 2 things together, add them together, you can subtract them, or you can find common solid volumes. In this case, I want to add all 3 together, and I can select them right from the graphics area. Okay, there is a little preview option here, shows what the result looks like. And when you accept the command, again, my solid body folder disappears because now this is one solid part. Okay. Back to my air source part here. How do I take a body and make it into an assembly when I've went through the process of designing everything in a single part? Maybe it made it easier for me to do my sketching and creating relationships between the features. How do I turn that into an assembly file? Well, if you were to right-click on the Solid Bodies folder, you're going to have an option in there called Save Bodies. If I select Save Bodies, the software is going to take a look at how many solid bodies I have, and it's going to give me an opportunity to name each one of those solid bodies. And I'm going to auto-assign names. Let's see, here you go. I use the auto-assign names, but you could come in here and manually type in the individual names. You can also determine where the origin of the assembly needs to be. Now, sometimes you're placing this into another assembly where you're going to tie the origins together. I can place my origin wherever I want it. Now I can also, which is really neat, take the custom properties that I've filled out relative to the part and have them copied to each individual part. Now some of you are probably saying, why don't they have that for regular functionality? Just copy these to these. Okay. Now here's where we say not only do we want to save the parts, but we also want to create the assembly. So it requires me to browse, give it an assembly name, and a location. And the last thing it's looking for are the templates, one for the part, for all the parts it's creating, and one for the assembly, making sure you match the units. And what the software is going to do, I'm going to let it go ahead and chug for this, is create an assembly with all the components fixed in place, with a link back to the original assembly. What's neat about this is if you change the original multi-body part, the resulting assembly will also change. Okay, so let's go to that assembly real quick here. There's my assembly, and you can see we did lose some things, lose some colors. Those were face colors, not part colors, so they don't get brought forward. But all the files are here. They're named properly and positioned properly to create the assembly. Now one other method I want to point out, if we go back to our part here, I'm going to actually delete the feature. There is a command also called insert into new part, and you can find that in the solid bodies folder. Find any item, and there's insert into new part. Now insert in a new part allows me to create the part file for that individual item, give it a name, but it creates a link back to the original as well. You'll notice the external reference icon. Therefore, once again, if the original multi-body part changes, this particular file will change as well. Okay? I'm trying to illustrate as much as I can off this one. Now, what if I wanted to create, I didn't want to create an assembly, but I wanted to create a drawing of this assembly, and then detail out the individual components. Well, we know we can come in here and say, let's make a drawing from the part, select my units, select my size, let's do something a little bigger here, and I can place views of the individual part, which it contains multiple solids. We know how that works, and we can place all those in at the assembly level. Okay, makes it easy to do. But what if I wanted to create a detail of maybe the housing? Okay, if I wanted to do that, there's a command called relative view. This is used in the weldment environment, but if I select relative view, you select the view that you're creating the view from, and it's going to automatically open up that part for you to determine the direction that the view is going to be. But where it adds functionality pertaining to multibodies is this section here under scope, where we can tell it selected bodies, and we can say, you know what, just this part, just that solid body. Okay? And then we can start to determine what is the front of this part. If I got any flat surfaces here. I'm not sure I do. Okay, there's the front. And let's see if I can find a flat surface to be my right surface. Not much flat on this part. It does need another one. Let's see here. And that's my right. And now, once I've made those selections, I now can place that body in there individually, just like we would typically do by detailing out an individual part. From there, you can project views off of it, and I'm just going to run out of paper space doing this, but you can see how we can now detail out as if it was an assembly. Okay. Just wanted to point that side of it out. Now, let me delete these for a moment. I want to show a couple other tips and tricks in here as it relates to that. Now, what happens if we put a multi-body part into a bill of material or into an assembly for a bill of material? Let's just do it on the particular part, because realistically, we'd want a bill of material of this. If I didn't want to create an assembly, I'd still want to be able to do things like ballooning and bill of material. But what happens if I insert a bill of material in here now? Okay, if I insert a bill of material, it sees it as one item. Now that's where we get into the whole SOLIDWORKS idea that, you know, if it's a part, it's one item in the bill of materials. Now, I'm going to show you a little trick to, I guess that's there to get around that in a lot of ways. We talked a little bit about making something a weldment. If I were to insert the weldment feature here, what that does for me is it automatically creates and changes the solid bodies folder to a cut list folder. Now in SOLIDWORKS, that's a trigger so that now these items will show up in the bill of materials. Now if I right click and update the cut list, which is something you do to organize them into individual folders. A lot of times it's one item in each folder. If the software is able to understand if there's more than one of the same solid. What happens then is you can now apply properties to each of the folders, like material. We knew about material because we can do it per body. But things like description. If I want to describe this as you know, whatever this happens to be, I can type in a description. Okay. Now here's the real kicker in this. It's really not a weldment, right? We're not welding anything together. It's a multi-body. However, if I were to insert that table now, insert my bill of material table, we have the ability under BOM type to do an indented BOM, and then we have options as to the numbering of the subcomponents. Now it's thinking indented. It didn't give me the options before. It just, you know, it created a top level because there was only one. If I do flat numbering, look at that. Now it's able to see that item number 1 is the assembly portion, and all these are subcomponents. If I expand this out, all it's really doing is, you know, looking at each body as a separate item. Now it's up to you. Notice my description came in. It's up to you to fill out all the custom properties related to that. Okay. This is one gotcha with that. We're used to being able to double click a cell in the bill of materials and have it drive automatically back to the individual component. That does not happen with these. You have to fill them out by going to the properties, and in this case we'll add another description and throw something in there, and you'll notice that it does show up on my bill of materials. Once we rebuild here, it should pop up for me. There we go. So that is one way of kind of making something that you've designed as a single part into something that's useful for placing in another assembly. Now, having said all of this, let's close this down and discard all these changes. How do I take an assembly and make it into a multi-body part? So how do I go the other way? I'm going to close a bunch of this down. We're not saving here. What if I had the original air source assembly? Okay, I'm going to open it off this drawing here. And I wanted to make, this is the actual assembly, but I wanted to make a multi-body part from this. If I do a file save as, one of the options is to save as a part file. As part of that, here's our options within the Save As dialog that says what geometry would I like to save. My exterior faces, exterior components, or all components. These last two are going to create a multi-body part. If I select all components and do a save, that's how I got the air source to be looking the way you would expect it. Window, I think I just got to open it from there. Air source part. And here's the original set of bodies that we started with. Now, the only problem with going backwards like this is you lose your feature history, but you can continue to organize and work with it from there. Now, continuing on, we're kind of running a little bit back on time here. Let's look at a couple options here. We've already talked about feature scope, but how do I take something that's maybe already connected together and break it into more than one body? There is a command called split. Insert features split. Now the neat thing about what you can use to split apart is it says as I mouse over it trimming surfaces, but this can be planes, flat surfaces, or sketches. So for my tools I might pick a sketch, I might pick this face and this face, and then I tell the software to use those to cut the part. Now when you use sketches, it's as if it's extruding it in both directions through a wall. Anything it intersects, it breaks apart. Anything that it now sees as a separate piece, it's asking for a name. Okay? And I, again, can auto-assign some names here. I do have the ability to assign a part template to this. I do have the ability to copy any custom properties and set my origins. Notice what does not exist here is the ability to create assembly. Okay, that does not exist in this command. Okay. Now I have each of those as individual components or individual solids within an upper level solid. They can be hidden separately and worked with separately. So if you design something as a whole, there's nothing saying you can't break it apart into smaller pieces. Now that being said, we can also take something that exists and insert other solids into it. There's a command called insert part, where I can come through and insert any other part file into the one that I have currently open. Now when you do that, it asks you what information would you like bring it. Solid bodies, surface bodies, axes, planes, sketches, all those different things. And it's going to have a link to the original part unless you say break the link. But now I can come in here and place the component in there. It happens to be just a washer bushing in here. Now this brings me to another topic I had on the list. which is locating those bodies. Now we have a very simple translate tool where I can pick the body, give it an XYZ location. Or if I select constraints in here, it's also going to allow me, and this is where the lines really blur between parts and assemblies, because in the last few years they've added the ability to mate bodies for positioning. So I can come in here and say, you know what, that face and that face are coincident, and add that as a mate. I can come in here and say that face and that face are concentric and add it. And now that body is positioned to stay, so if any of those things change, that body is also going to move, not dynamically essentially like it does in an assembly, but it still gives true positioning of those items. Okay. Now I didn't add those all the way, but you can see how it does position them. On that same topic, exploding multibodies. This is another blurry line between parts and assemblies when it comes to multibodies. This was added in 2012. We now have the ability to create exploded views of multiple bodies. And the great thing is it works exactly like it does in assemblies, where I pick a component, I drag it out. Except now I'm not really picking components, I'm picking just bodies. Pull that one out, I can grab this and pull it out. Now, what do you lose with this functionality? Because there is some loss. When you create this explode view, you will have another configuration for explode view. If you right click, you can collapse. If you right click again, you can explode. What we can't do in a multi-body environment is animate the explode and collapse. Doesn't make sense. I think it will probably be there. I would assume so. It's not far behind. But it gets a little bit, again, gray in there. Now how about explode line sketches? I could go ahead now and insert an explode line sketch that shows how parts connect together. I can select maybe this cylindrical item, select this cylindrical item, maybe, let's see, there, and this cylindrical item, and it will actually create an explode line sketch, again, in a part file that is a multibody. So these are some of the things that have intrigued me about multiple bodies. We can now blur that line between a multibody part and its solids. It's integrated throughout the software in a lot of different commands. We can create folders. We can make it show up in the bill of materials. We can get mass properties. We can insert them into their own parts and save them as bodies separately. So there's quite a bit there when it relates to multibodies. I appreciate you coming to sit to the webinar. I hope there was at least something you were able to gain from this. As far as technique goes on when to use multibodies, it's really situational. When you're having trouble making certain features work, try disconnecting that portion of the solid and performing the operations at a more local level and then combining them back together. A lot of times the less complexity to what it's trying to solve, the easier it is to solve it. Now we have one question. When I made the multibody into an assembly, were the parts fixed in place or floated by default? The parts were fixed in place as they existed in the part file. So they were automatically fixed. I did not have to do any more work to those. I'll be here for another couple minutes for questions, but I want to thank everyone for attending and remind you that on our website we have 2 more for next month. One, we're going to go through drawing view creation all the different options for drawing view creation, and the other one is drawing annotations and all their options. So if you want to sign up on the website, that will get you a seat for the 2 next month, and we're heading off to SOLIDWORKS World this weekend. I hope we can see some of you folks out at SOLIDWORKS World in San Diego, California, and we'll surely be hearing some real neat news about what's next in SOLIDWORKS. So thanks for attending. Talk to you later.